Drum roll. Are we recording? Okay, I'm going to build the CMOS BDC crap clock, which is its official name, otherwise known as David Watt's binary clock. BDC stands for binary digital clock. That's right. Nope. I've got some free time. My fiance is in the bath with some Prosecco. Everyone else is out. My babies are asleep for now. I've got myself a drink. I've had a couple of drinks, so this will be interesting. But I've got my hardcore drink, not whiskey like David drinks, but this is white rum, coconut and lilt, which is like a tropical fizzy drink in the UK.
Pineapple and grapefruit.
That's very good. And I've also got some cookies, which are white chocolate and raspberry cookies from Sainsbury's. That will keep me going. I've got some cameras set up. I'm not going to film it all, it'll be pretty boring. I wasn't going to do a live stream or anything crazy like that, but I will film what I can, give you the highlights, and hopefully at the end of it we will have a working clock. So I've got a setup. I've actually forgot my big mat, so I've got my small mat, got the kit, instructions, a soldering iron, pump just in case, some brush, the solder, a not so helpful hands, bit of flux, you never know, cleaner to keep everything clean, there's lots of SMD stuff. My trusty multimeter, I've got some IPA alcohol to clean the PCB. I've got my tweezers for the SMD stuff. And I think we are ready to go. For those of you that don't know, the BDC, or the binary digital clock. Okay, I go through this whole video calling it the BDC, which I thought was a binary decimal clock, despite looking it up on Wiki. But it's the BCD, which stands for binary coded decimal, which makes more sense because this clock is showing you the decimal number in binary coded format. Back to the build. It is a type of clock that you can read using binary numbers, and it has 2 columns seconds, 2 columns minutes, and 2 columns for hours, and it's numbered 1, 2, 4 and 8, and between those you can read the time, the hours, minutes and seconds based on binary, and you add up the digits and it'll give you a number. That's the theory. I've never used one, I've never had one, but I've been watching David build his binary clock. It's been very exciting, finally worked out how to read it, and all of a sudden I actually wanted one. So you've seen in a previous video, which I'll put up here, I got the package from David, who's very kind enough to send it over to me. By the looks of it, I think I'm the first one to get it. It was shot over in super fast Royal Mail. I think I'll be the first one to build it as well. And in the previous video I spoke about how we were going to do a little swapsy. So once I've actually built this, it's not over. I'm going to try and design a 3D case, print it out for him and probably send him that case as well. But we'll also get all the STL files, all the digital files. So when you get the kit, David has actually done a very good tutorial video of actually assembling the kit, and that is way better than what I'm going to do. So if you need instructions, I would use that. I assume he's going to get it as a public video at the moment. I think it's private or unlisted, but that's way better than what I'm going to do. So don't use this as an instructional, just use this as a bit of fun. Hopefully we'll get no interruptions, everything will go fine, and we will have a working clock at the end of it. So without further ado, hang on, let's do this Sean Hodkins style. Without further ado, so I followed David's video and I know the order of which to do it. So let's just get going, shall we? And try and get this built. Lay all the components out. We have the clock. We have some stickers. This is the circuit board. It's very cool. CMOS BDC crap clock version 1.1. So what we've got to do is put in all these ICs, couple of ICs, do all the resistors, some diodes, the crystal, some capacitors, some more capacitors, the switches, the headers, and then all the LEDs. Some cool little stickers, very cool. David Watts, all the components, put them in rough order. That will do. First, got some of these ICs. I'm going to use this not so helpful hands. Just keep everything roughly secure. I despise it. It's good for me. Supposedly there is a dot on this. Okay, here we go. A little bit of solder on it. Place it where you want it. That's as good as I'm going to get for this one. It's that leg. Let me turn this sucker down a bit. You don't need to watch this. Okay, that was horrible. I've done the ICs. I need to go over them very carefully to look for any shorts. This one is very wonky, but they are done. That is incredibly difficult and horrible. I would not wish that on anyone. So let's move on to the next thing and get this thing done, because I am way over time. Resistors are done. That was a lot easier. And I see what you mean, David. When you're doing these resistors, it's very therapeutic. It was a lot of fun, very nice and relaxing. That's them done. On to the next. We are rattling along. We've now got the diodes, the capacitors, the crystal, and the crystal's two little capacitors. All we've got left now is the LEDs, the switches, and the headers, and the big power capacitor. Okay, we've got the big capacitor in, we've got the headers in, and we've got the switches in. So all that's got left now is 20 of these LEDs. So once that's done, we can power it up. And it is done. 20 of the LEDs all soldered in, all looking straight. The back's a bit of a mess. I'm just going to tidy that up with the solder after I've cut everything. Burnt myself about 3 times on the solder, on soldering iron, which is not good. But it's all done. I'm just going to check over all the solder joints, especially on the ICs, and then I'm going to power it up. So the LEDs were done, moment of truth, just needed to be powered up. I've done that. What's the results? Don't forget there's 2 jumpers. One on the back is the LED enable. If you don't put the jumper on that, nothing essentially will look like it's happening. And then you've also got the clock, where it's a 1 hertz clock, or a manual advancement where you use the 2 push buttons. So don't forget to put them in. But good news, here it is. If I can get my jerry-rigged power supply stable. Ta-da! 1 binary clock by David Watts. As you can see, it's currently set in 1 hertz clock mode, so it's essentially running as a clock. And you can see the seconds, bring it a bit closer. You should see the seconds are ticking away, which goes on to the next seconds, and when the seconds fill up, it increases the minutes, and these are the minutes, and these are hours. So if you read it, it is 1, so that's 13, 4, 50, 1350 and 1, 8, 9, 20 seconds, about, or thereabouts. It's incredibly late. It took a lot longer than what I thought it would take. Many of the ICs are absolutely nerve-wracking soldering those, but checking them over, they actually look pretty neat now. What I'm going to do is just tidy it up and give you a full rundown of the process and what went on. But yeah, I'm really chuffed. Here it is, David. First one done. It works the first time, which I was amazed at. I thought I would blow some IC with my really bad soldering. Really happy with it. It looks really good. The LEDs are ultra bright white straw hat 5mm LEDs. So they're very dotty, very binary. That's a good descriptive. They're not, they're not diffused or anything. They are very much on or off, and it's a really good looking display. It looks great. It looks absolutely great. I can't wait to design a case for it. I'm going to show off the front as much as I can with it because it's a cool geeky looking thing. I loved how this just running on my desktop. That's a power supply coming out. It's running on 5 volts, just on this breadboard power supply. But yeah, all for now. It's a bit late. I'm going to go to bed, finish my last cookie. Cheers. Oh, that bit was strong. Okay, so it's been a couple of days and I've enjoyed this clock, so I thought I'd give a little final summary review. That was one tired guy at the end of that clip, but now I've had the binary clock running and it is still running. Ta-da! A little bit closer for you. I'm sorry if this blows out your screen. I'll try to set my camera so it shows it all. It's keeping good time. Still, it's been running over 24 hours now and it's still showing the right time, which if you can read it is about 7:43. See, and I'm getting better at telling the time on it as well. But there you go, I'll keep this running. Instead of using that breadboard power supply, which was a bit of a jerry rig and actually caused an issue when I was trying to get it working, I actually thought the board was broken. Sorry, David. But it was actually the crappy little breadboard and the power supply. So what I've done for now is I have a jumper cable. So you can see that. It's all shrink wrapped and it's connected to, wow, capacitance. Connected to a USB socket. Plug that back in. It'll keep on ticking. And it keeps ticking because the logic gates remember their state essentially, which is why you have a reset button on the back. Hit that and it'll basically go to 0. So let's have a quick recap. David has got a good build video. I would recommend you watch that. It's a hell of a lot better than the video that you just watched, and it's a good instructional video. And if you follow that, you can't go wrong. I followed it just for the parts, but I didn't actually watch it fully carefully. I just skimmed through and I thought, nah, I know how to solder, I can get this done. And then I came into a couple of issues, which I thought, oh, that was a bit odd. Actually, when I looked at the video, David had already mentioned it and he said, yeah, you'll get that. So the first one was the size of the pins for your main chips, which are the 4510s. They're very close to the pads, so when you're hand soldering them, very tight to get the solder iron in. Compare that to the 4060, which is this one on the end. You get a lot more space with the pads. So if you're unsure about soldering ICs, I would probably recommend doing this one first, because you get a lot more room between the pin and the pad to get your solder and your soldering iron in, and it'll flow a lot nicer. A little bit wary on that, and that's why I kind of got stressed out and stopped filming and turned it into just some little clips. But that's okay. The other issue that I came across was the silkscreen footprints. It's so minor. It's so minor, David. There's a couple of the resistor silkscreen numbers that are inside the LED silkscreen. So where you're looking for the 470, you can't see it, but if you can't figure that out, it's a 470. You shouldn't be soldering this kit. It was just minor little, ooh, that would be nice just to tidy up the board if someone wants to print it themselves, just so it's perfect. And the other one, which I thought initially, it almost caught me out, but when I watched the video back, David actually mentioned that, but it would be handy to have footprint, just a little footprint silkscreen, so you know which way. And that is these two resistors down here. So you've got a 6.8 mega ohm and a 330k resistor. Now, looking at the silkscreen, with the way the labels are labelled, you'd think all the resistors go that way, like horizontal. But in fact, you've got a horizontal one, and you've got two vertical ones. So when you're soldering the first pad up to place the part on, I actually thought the pads were bigger. They were spaced wider apart, and I thought, that's odd. That's a bit strange. Why has it got wider spaced pads? And thought, oh, hang on. I looked at the traces and realised that I was going to end up soldering them horizontal, and that would have just, God knows what that had done. But if you look at the video that David did.
Now be careful when you're soldering these ones, because it does look like they could go across, but they definitely go up like that.
But maybe just a little board revision, David, is just stick some little silkscreen footprints so you know which way they're going. Other than that, it was perfect. It still amazes me. I still don't understand the logic behind it. He's done a few videos, and I've got the schematic. You know, these are what I call old school CMOS chips. I started my electronics background initially at university, doing logic circuits, which I just didn't understand. But now I've come into electronics from an Arduino side. So for me, it's all about throwing up a sketch, programming, coding, and making it work. And there's loads of people that have done these, and even when David's been doing it, they've said, well, why don't you just stick an Arduino on? Why don't you get it done in code? But he didn't want to do that. He wanted to do it in logic, in the actual hard-coded chips. And it's mesmerizing to know that it's all working, and it's great. You can see the video that I'm doing in the background. So this is the summary of it. I did go into how the clock works at the end of my video, but I look tired. I look knackered, and it's amazing how it helps to have a lot of light in this lovely light office. I can see all the resistor values and the IC chip names and everything. But when I was doing it that night, I was running a little blind, which was quite bad. So yeah, when you're doing this, make sure you've got a well lit environment. Now, I cleaned this up. I used IPA alcohol. However, it's incredibly dirty. The IPA is just left a big smudged. I used IPA in a toothbrush, but it didn't seem to work. So if you've got a better solution to clean up these circuit boards, because I kind of want it back to how it was. It's nice and glossy with the Osh Park purple. It's kind of made it look a bit slimy, which I'm not happy about. But if you've got a solution, stick it in a comment below. Tell me how to clean up my circuit board. Be much appreciated. I still haven't finished it. There's a couple of wonky LEDs on the board, so I just still need to tidy up the soldering and just clean up the ends of these leads. It's a bit of a mess. I couldn't find my little angled snips, so I had to use these big wire snippers, if you see on the video, and it wasn't very accurate. So if you want to set this clock, it's not a clock. It's basically just counting time. So you start from 0, which is essentially midnight, and you have to run through the time. So when you do get it running, don't think, well, how am I supposed to set the time? And when you do set the time, it's a lot easier if you set it early in the morning, because you're starting from 0 and you have to loop through all the way up to whatever time. So if you're going to set this at like 10 p.m. at night, you're going to have to get all the way to 2200 from 0. So David has got this very handy clock signal that you can change and using the buttons, 256 Hertz and 32 Hertz, and you just cycle through them. That's 256 and it whizzes through. I'm going to totally mess up my time now. And that's 32, so it's got a little bit slower. Let's hit the reset button. Reset to 0, and you can start whizzing through. So we are on 752. What do we need? 4, 5, 6, 7, and 3. Right. 1, 2. Hang on. As if by magic, we're kind of on the right time. Which brings us on to the expansion of the project. Me and David have spoken, and I'm wanting to build a little 3D case for him and the whole project, so you can put this on display, put it on your desktop. Got a few ideas from it being battery to USB, or just raw power pins, just so it's a bit of a case to keep it neat, keep it tidy, keep it safe. But then David has also alluded to keeping the time as well. So it's running off a 1 Hertz clock signal. So he spoke about using a GPS module that will give you essentially an atomically correct 1 Hertz signal. But then I'm also thinking about using an RTC, real-time clock. I believe, I've not looked into it, I think they output a 1 Hertz square signal, I believe. But it would be quite useful to have this running, and if you unplugged it and plugged it back in, it would keep the time somehow. You might need a microcontroller, because essentially you'd have to take out the LED enable pin, and then when you plug it back in, it would fire it up and the clock would be running. I don't know, it's a bit of fun, it's just a little toy, but it would be quite handy to have it as an actual functional clock that you can carry about from place to place and use as a clock that would keep time if the power went out. I'll show you a quick little render of where I'm at with my case. It's getting there. It's a really simple case, 2 parts, a back and a front bezel that should just snap together. So thank you, David, for this project and this board. It was really much appreciated that you sent it over. I'm glad that I built it. You've made an absolutely fantastic board. It's absolutely perfect. Apart from those little niggles, like I said, it's nothing. If you actually watch the video, it's not a problem. I just skipped ahead because I thought I knew what I was doing. But it's amazing, absolutely. It still amazes me that it's all just hard-coded logic and it's just doing it all off however it works. Magic, unicorn dust. It's fantastic. It's a real cool project. The PCB and the silkscreen is really cool as well. I like the digits and your little logo. And the stickers that you sent through, that was cool. It was a nice little kit, and the instructions in Chinese, again, that was just a genius move. Keep it up, get it going, get the other crap clock as a kit. I'd love to build that, everyone else would love to build this. Get these on Tindy as well. I know you were waiting for me to see if it worked, but yeah, it worked fine, it was fantastic. Yeah, check out David's channel, stick it up there. It's been fantastic, really enjoyed it, and hopefully there'll be a follow-up video of the case. So if you've enjoyed this video, don't forget to give it a thumbs up. If you're not subscribed to me, please do so. I need some subscribers. And smash the like button and love it and share it and tell your friends and leave a comment about cleaning up a PCB to get it back and shiny again. And if you have made it this far, thanks for watching. Cheers, guys.